this video, we're going to look at ways to compare two variables using R. Before we get started, there are three files that you'll want to have. As always, we want to make sure that we have our code book handy. You'll want to have the R script from this module downloaded onto your computer. And then in this video, I'm going to be using the Kentucky dataset that we created earlier. You want to have either the Kentucky dataset so you can follow along exactly with the video, which I do recommend before working with your own state's data, or if you want to go ahead and work with your own state's data, you'll want to have that data set ready. So the first thing we're going to do, I just wanted to show you as a reminder how you can open up a file using R. So here I've got RStudio open. And actually, before I do that, one other thing that I do want to just remind you of is over here you'll notice when I first open up RStudio that it says that my environment is empty. If you have some other things in here when you first open up RStudio, those are probably things from another session. It's generally recommended to go ahead and delete everything out before you restart something new or start something new. And the reason for that is sometimes old variables, they might have the same names and they can kind of cause errors later on down the road. So if you have some things here, what I would recommend doing is clicking on the broom, and it's going to ask you if you want to remove all objects, and the answer here is yes. Typically this happens if when you go to close RStudio, it's going to ask you, do you want to save your workspace? Typically I always click no on that, and I highly recommend that you do the same. Part of the reason that we work in scripts is because we know that once we write a script, we can always just rerun that script to reproduce everything. And that's typically the best way to work. Alright, so let's see how to open the file. So here I'm going to click on File, I'm going to click on Open File, and I'm going to open up that R script that we're going to work in. And so this is the folder on my computer for this module. If it didn't automatically open the folder that you want to be in, remember you can always click up here or over here to navigate on your computer where you want to be. And so the file that I want is the Module 8 R script. And we can see that that opens up. I'll go up here to the top. And then the other thing I want to make sure that I know where it is again that data set that I'm going to work with. And in this video, I'm going to work with the Kentucky data set. So there's two different ways that we can read that data set in. First, we need to set our working directory. So our working directory it tells R where the file is located. And so you'll notice here on line 10, I have set working directory, and in there I have a file path. So you can either edit this directly, or the other thing that we can do is we can come over here and we can navigate to where that file is located. And we can do that by clicking on these three dots right here. And then we're going to navigate through the computer until we have the spot where our files are located. So I'm navigating to that spot on my computer. Right, and remember that as you go through this navigation, it's not going to show you any of the individual files, it's just showing you the folder. So I know that this file is in the Module 8 folder, even though it looks empty here. And again, that's just because it doesn't show files, it only shows folders. So I click open, and then I can look here and see that file is in this folder. Then I can click on More, Set as Working Directory, and that will actually generate the code down here. And so what I'm going to do is just copy that code, and then I'm going to come up here and I'm going to paste it. So that next time I open this file, if I want to rerun this code, I don't have to go through those steps. I know the working directory has already been set. Next, I'm going to read in the data set. This is going to be very similar to what we've done before. I'm using the read.csv function. So I'm giving it the name of the data set in quotations with the .csv after. And I'm setting header equal to true, and this is because I know that file has the variable names in it. And I'm going to call this object Kentucky 2020 data. I'm going to run this, and I can see that it appears here. I'm going to run the view function just to take a look at the data, just to kind of scroll through and make sure that everything, I don't see any big red flags. It looks about like what I would expect. And then I want to check that I do have that number of observations and the number of variables that we've seen in the previous videos, and I do. So this suggests that I'm, okay to proceed. All right. Now, since I did change that working directory up here, notice that my file name is now kind of a light blue and it's got a little asterisk next to it. This is RStudio's way of reminding me I haven't saved this file yet. So I'm just going to go ahead and save that. You'll see it turns white, and I usually try to do that anytime that I've made changes. All right, so we're first going to learn how to create a contingency table. And remember that a contingency table gives us a way to compare two categorical variables. So the two categorical variables I'm going to compare in this video are the EDUCA variable and the diffwalk variable. So let's go to the codebook and see what those variables are. So here I have my codebook. Now the codebook is really long, it's 161 pages. So just as a reminder, an easier way to navigate the codebook is to use the search. And so if you're on a Windows computer, you can hit Control F, or if you're on a Mac, Command F. And so what I'm going to do is I'm just going to search for these variable names. We've got the EDUCA. And I see that this variable is education level. Here are the different levels for this categorical variable. And then let's also look at our second one, which is the diffwalk. And we see that this variable is looking at whether or not a person has difficulty walking or climbing stairs. And the levels are yes, no, don't know, not sure, refused, and not asked or missing. All right, so first thing I'm going to do is I'm going to pull the EDU variable from the data set. And so you'll notice I have the data set name, $, and the name of the variable. And I'm going to set that equal to EDU var. And so this will be an object that I can work with that's going to have all of the data for that EDU, the education variable. And I'm going to do something very similar for the walking variable. And so notice I've named this one walk var. Both of these are a choice that I have made, so I get to call these whatever I want. Whereas on the right hand side, I have to call the data set name exactly as I specified it up here. And the variable name has to be exactly the same as what's in the codebook. So as always, the first thing I want to do is explore the number of missing values for each of these variables. And so we've seen this code before. So here I'm going to run this first for the education variable, and I see there are no missing variables. And for the walking variable, I see that there are 73. And so I've made a comment here that just says no missing values for the first one and 73 for the second one, and I've typed that there as a reminder for myself. So remember that comments are for you. They're there to help you understand the code, and they're there to help remind you of maybe what some of that output was, because none of the output gets saved. And so again, part of the reason that we write scripts is so that I can always reopen this, I can rerun this code, and down here I'll get the same values again. So we're going to make a contingency table comparing these two variables, and we're first going to do this using the table function. Now how the table function works is you're going to put in both of the objects separated by a comma. Whichever one you list first will be represented in the rows, and whichever one you do second will be represented in the columns. So if we run this first one, notice that the walking variable is represented in the rows, and the education variable is represented in the columns. So, for example, there were no people who gave a response of 1 for education and 1 for the walking variable. So going back to our code book here, that means that no one said they had difficulty walking, and if we go back to our education, did not continue high school, or did not graduate high school rather. All right, now we could switch these and have the education variable first. And I'm going to make this window larger, and notice if we compare these two tables, again, for this one, walking is along the rows and education is on the columns. Now education is across the rows and the walking variable is in the columns. Now I want to work with the table where we have education in the rows and walking in the columns. So what I'm going to do is I'm going to name this to be a new object, and I'm going to call it edu walk table. So this is a name that I've chosen. And so what I've named this is something that I can recognize later on what this object represents. I know this is a table, so I put table at the end, and then I put some letters separated by underscores to remind myself what two variables are being compared. So if we run this, notice that the table doesn't appear down here, but I now have a new object up here called edu walk table that is a table. Now, one of the things that makes this table hard to read is that it still has the numbers that represent the categories for each of these variables. So to make it easier to read, it would be nice if we could put some labels on there. And we already saw this when we looked at frequency tables, so it's very similar. But now I want to add both row and column names. So I want to add row names to my table, and I know that the rows are represented by education. And I see for my variable that education had, data for the values 1, 2, 3, 4, 5, 6, and 9. So again, what I'm going to do is go back to my data set, and I'm going to look at what each of those values represent, and I'm going to write labels for those. Oh, and I do apologize. I just realized in this video I actually pulled the wrong education variable, so let me correct that here. The one that we're working with is educa. Notice this is educag, so that one is slightly different. So again, lots of variables in this data set, so we do need to be careful. So here's the actual data set that I'm working with, and here are the values that it takes. All right, so we know that a 1 is kindergarten or less. 2 is elementary, and you'll see that each of these I've put in quotations, and we do this because these are what are called character strings or names, and each of them are separated by a comma. And I've done something very similar for the walking variable, so let's go and look at that variable. We see that the 1 is a yes, 2 is a no, 7 is don't know, not sure, and 9 is refused. So again, very similar to what we did before with the frequency tables. So here I'm assigning both the row and the column names, and now I'm going to call that table again. And notice this time I actually have labels for each of my rows and each of my columns. Now, one thing we need to be very careful when we do this, and this is one place that you might see an error message, you have to make sure that the number of labels that you give it matches the number of columns or rows that you're trying to label. So, for example, let's say that I tried to add on an additional label. Okay, and if I run this now and try to add on these new labels, it's going to give me this error. It says error in dime names. That means dimension names. In other words, the number of labels you gave it did not match. And so let's try and see what happens if I give it too few labels. So it needs 4, but what if I only give it 3? Again, it's going to give me that error. And so this is a really common error that you might see. If you see anything that looks like this, always go back and double check this step and make sure that the number of labels matches either the number of rows or the number of columns. And you can do that by looking at the tables that don't have the labels. Majority of the time this is going to match what is in the code book, but every once in a while you will run in a situation where, for example, let's say in the code book the 9 was a refused, but no one in your state refused to answer, and so these end up being all zeros, and so this one gets left off the table, and so your data set might not match exactly what's in the code book. So always check these tables for the numbers of rows and the number of columns, and make sure the number of labels that you have matches that. I'm going to run this again, and then again check my table. Everything looks good. All right, so why did we need to check those missing values at the beginning? So the reason for that is we want to be careful when we go to calculate what are called the marginal frequencies. And so remember, the marginal frequencies are the counts for each of the variables individually. So, for example, suppose I wanted to find the marginal frequencies for the walk variable. I can use my table to do that. So I'm going to use the margin.table function. I'm going to give it that object that is my table, and I'm going to give it the number 2. And so what this is going to do is this is going to sum and give me those marginal counts. So let's look and see what we get here. Right. So what it did was it gave me the counts for my walking variable. The total number of yeses, the total number of no's, the don't knows, and the refuses. If we change this to a 1, it's going to do the same thing, but for education. Now, let's do this. Let's compare this table that I used the margin.table function to get to the table function that you saw in an earlier module. Notice that the values we get are exactly the same. So the second one is how we saw to get a frequency table just using the single variable. The top way on line 44, this is showing you how to take your contingency table to get your frequency table. And so again, this was how we would get the counts for the column variable. We already saw to get the row variable, we just changed this to a 1. And so here is our education variable. And we could compare that to how we saw previously to get the counts for the education variable. But notice this time the numbers are slightly different. So what happened here? So notice we've got a 1, but we've got a 94 versus a 98. We got a 179 versus a 173. We've got a 839 compared to an 864. So what happened? Why are these numbers now slightly different than what we saw before? And so let's think about why that could be. If we use the first table and we were to sum up all of the counts, we would have this value right here. That gives us a total of 2,796. If we use the counts from the second table, which is what we did in earlier modules, we get that 2,869. And we know that education didn't have any missing values. This is the total number of observations in the data set, so this is the number that we expect. So why is this one right here low? And the reason for this is it has to do with the missing values. When you go to create a contingency table, so let's look back at our contingency table, notice that for each of these cells, the people represented in those cells had to give an answer for both the education variable and the walk variable. So for those people that there were missing values for the walk variable, even though they had a response to the education variable, there's no way to represent them in this contingency table. And so if you'll remember, there were 73 missing values for the walk variable. Well, if we look at the difference between these two total counts, I'm going to move this up a little bit. So we had the 2,869. If we subtract from that the 2,796, notice that gives us our 73. So we want to be very careful when it comes to using contingency tables to get us back to our frequency tables, because we have to account for that missing data. And so here, since there were 73 missing values for the walking variable, we see that our counts for our education variable, if we move from the contingency table to the frequency table, is going to be, losing 73 people essentially. And so this is why it's so important that in the footers on your tables, you recognize there were 73 people who had a missing value for the walking variable. So that way, when someone looks at one of your contingency tables, so for example, if you had this table right here in your report and they were to count up all of these frequencies, they would say, wait a minute, that doesn't add to your total number of observations. But if you have a footnote on there that says there were 73 missing values for the walking variable, then they would be able to count these frequencies plus that to get back to the total. So this is one reason it's so important that we always document how many missing values there were. Now we know that since we're working with sample data, we typically don't want to give counts. We would much rather give frequencies or relative frequencies. So let's talk about how we can do that for a contingency table. And remember that when we work with a contingency table, we're generally going to give what are called conditional proportions. So we could use the prop.table function. And so what this one is going to do is it's going to take our EDU walk table that we had up here, and what it's going to do is it's going to give us the relative frequency divided by the total number of people. So in other words, if you were to add up all of these frequencies here, or relative frequencies, in this table, they would add up to 100%. These are typically not that useful. Really, what we want to do is we want to give what are called conditional proportions. And I'm going to run this next line of code. This is, oops, I've got the wrong table in there. Let me fix that right now. Here we go. That just removed the number of significant digits here. But again, if we add these up, we're going to get 100%. So again, these really aren't that useful. What we really want is what are called the conditional proportions. And so let's look at what that looks like. We could look at the row percentages. And so here, if we look at the row percentage, what this is going to do is it's going to condition on education and then look at the distribution of the walking variable across levels of education. So, for example, what this tells me is given that someone had kindergarten or yes, 100% of them responded no to the walking variable. Now, this is a little bit deceptive because remember, if we go back to this variable and the actual counts, we only had one person in this row to begin with. So the count is very, very low for this row. Going back to our table, if we look at for everyone that was a high school graduate, so conditioning on being a high school graduate, we see about 25% of people said yes, and almost 75% said no, and then we've got some very small percentages in the don't knows and the refusals. Of those that are college graduates, we see that 10% of them said yes, where almost 90% of them said no. And so notice what this is going to do for us is it allows us to look at the distribution of the walking variable across different levels of education. And so, for example, looking at this one, we can see for those that were a high school graduate, we have a much higher percentage of them reporting yes, that they're having difficulty walking or climbing stairs compared to those people that are college graduates. And so if I'm interested in looking at whether or not people are having physical difficulties, especially if it comes to climbing stairs and walking, I would see that there is an association between education level and whether or not they have difficulty walking. As we increase in education, we actually see the proportion that are saying yes is decreasing. I couldn't tell that from this table up here. And again, even though when I look at this, I can see that there's a decrease, that means something different than it does here. Here we're conditioning on education and looking at that distribution of the second variable across different levels. If there was no association between education and the walking variable, I would anticipate that each of these rows, the percentages going across the rows would look exactly the same. In other words, if I know about education, that wouldn't tell me anything extra about walking. But in this case, again, we see that the yeses are decreasing and the nos are increasing, which tells me there's an association. Now we could flip this and do the same thing, but condition on the columns. And so notice if I switch this to a 2, now if I add up each of the columns are going to add to 100%. And so what this is saying is it's saying given that someone says yes, let's look at their distribution of education. So for example, if we look here, given that somebody says yes, 35% of them had a high school graduate, whereas of those people that said no, about 29% of them were high school graduates. For your report, what I recommend doing is conditioning on the demographic variable and looking at the distribution of your variable of interest. So again, what this is going to let you do is look at different levels for each of the different levels of your demographic variable. Is the distribution of your variable of interest, is it changing? And if it isn't, that's going to tell you there's not an association between the two. But if it is changing, that's going to allow you to talk about that association. And similar to what I did here, you can have those significant digits reduced. And so this is what that second table would look like if you reduce the significant digits. But remember, we're never going to copy and paste these tables into the reports. We're just using these to get the values. Now, looking at these tables that we created, we can see in the don't knows and the refusals, the counts are typically very, very low. And so that's why we would call these not informative, because the counts are incredibly low and they really just clutter our tables and our plots. And so for that reason, we typically want to remove those values, similar to what we did for the frequency tables. And then just as a footer at the bottom of the table, we want to say that those were removed. All right, so let's define the values we want to remove. For the education variable, if we go back to our code book here, right, we see that a 9 was refused. And then remember, for the walking variable, we had the don't know, not sure, and the refused. So any values you want to remove, you'll put them between the parentheses and separate them by a comma. Very similar to what we did with the frequency table, almost exactly the same. Here, to remove them, we're going to do the values remove location, same that we did before, except now we have a slight change because we're going to do this for both variables simultaneously. So you'll notice that I've got the edu var in the values remove, similar to what we had by the frequency table, but now I'm going to put a vertical bar and then do the same thing for my second variable. And that's going to give me those locations for both of those simultaneously. And you do have to do them at the same time. Right, running this. And then we're going to remove those others just like we did before. So we're going to do the minus values remove location for each of those variables. And then I'm going to create new ones. And since these are the second iteration of those, I'm going to put a 2 after them. Again, just like we did with the frequency tables. And so now I'm going to do the same thing that I did above, except I'm going to use my 2 new variables. Right? And so here, what I'm going to want to do is I'm going to compare the first and the second table I created. So here is the second table, my new one, and notice I've called it edu walk table 2. And I can see that it has removed those don't knows and refusals, and the refusals for the education variable. And then I'm going to take the sum of my new table just to make sure that in my documentation my new sum is 2,783. So I want to make sure that I denote that there were 73 missing values for the walking variable. And then also I want to denote, if I make the comparison between the tables, there's an additional 2, 4, 5, 6, and then 7 people that answered either don't know and refuse, or don't know or refuse for the walking variable, or refuse for the education variable. So again, that's something that I'm going to want to put in my report. So I'm just going to kind of make myself a comment here and say, in addition to the 73 missing values for the walking variable, also removed, and again I'm just going to go to the table and count my don't knows and refusals here. I had 5, 6, 7 observations with a response of don't know or refused for the education or walking variable were also removed. And again, notice the reason we're removing these is their counts are very, very low, so they're not informative. Now, if you find that your don't knows are 40% of your data, you probably don't want to do this, because in that case, that is going to be an informative category. But here, we're removing 7 observations out of almost 3,000, and so that's why these just kind of clutter our plots and clutter our tables. Similar before, we're going to add our no and column names. But now, remember, we've removed that don't know, not sure, and the refusals. So in my labels, those have now been removed as well. So if you get to this step and you're getting an error, it's probably because you either have too many or too few labels. So again, same thing we did before. I'm going to look at my table, and now oops, I've got an error here. Let's see if we can figure out what it is. So we're adding my row names to my table and adding the column names, running my table again. There we go. And notice now we've got, for the walking variable, the yes and the no label, and for the education, the appropriate labels there as well. So again, I went through this piece pretty quick after I removed the variables, but that's because this is almost exactly the same of what we just did up above, and then very, very similar to what you did for the frequency tables. So if you have questions on that, please let me know. All right. And so now I can look at those conditional probabilities. And so here I've got the distribution of the walking variable, or probably the distribution of education for the walking variable, but I actually want to change this. I think it's better to look at the opposite way. So notice as we look across the rows, these are going to add to 100%. And so what I'm doing is I'm looking at the distribution of yes or no conditional on education level. So for each of the education levels, I'm seeing is the distribution of whether or not someone has difficulty walking changing. And we can see that as education increases, the yes is decreasing and the no is increasing, suggesting there is an association. The only difference is in this kindergarten or less, but there was only one person in this row. So as you're building your plots and your tables, you may also consider removing this response and documenting it at the end of the table. So I do want to change this comment here because now we've made these rows. All right, the last thing I want to do is I want to save that table that I created as an object, edu walk table final. And so this table right here, again, this is the one that you're going to want to put in the assignment. Obviously not for these variables, but for your variables, this is the style table that you want. So next, let's start looking at bar charts. And so just to start with, I'm going to talk about bar charts with frequencies just for illustration, and then we'll talk about the type of bar plots that you want to make for your reports. All right. So here I've got a bar plot. You're going to notice that this code is very, very similar to the bar plots that you saw from frequency tables. So here I'm going to call the original edu walk table. So just as a reminder, this is what that table looks like. All right, so if we run this, notice that along the x-axis I have the difficulty walking or using stairs variable. I've got frequency on my y-axis, and then here for the different levels of education I have all these different colors. Now this plot is very hard to read for a number of reasons, and so that's why I wanted to show you this one first and kind of talk about how we're going to make this plot better. One is we've talked about how really what I'd like to do is condition on education, and then for each of those levels of education look at whether or not people have trouble walking. Well, part of the problem is whatever row we have in our table, R is automatically going to put that on the x-axis. So coming here on my code, we can use what is called the transpose function on our table. All you need to know is that if you want to flip what variable is on the x-axis, you put parentheses around your table name and the letter T. So that's all I've done here, and that's going to put education along the bottom. And then for each of the bars, that will represent the no's and the yeses. Now, if you'll remember earlier, I talked about how, well, actually, let's go ahead and run this, and we'll see what that looks like. Right, so that looks a little bit better. Now notice I do need to pull this larger so I make sure I get all those levels of education to actually show, so that does look better. We now have education along the bottom, and we can look at the distribution of yeses and nos. Now, a couple changes that I made besides adding in that transpose function. Notice that I've still got that my x-axis is difficulty walking or stairs. Really, that x-lab should now be education level. And here I had colors 1 through 7. That's because education had 7 levels, so I needed 7 colors, so I do 1:7. Now I've got the difficulty walking or stairs in the bars, and it only has 4 levels, so I've changed that to 1 to 4. So again, running this again, and for my legend, I've changed that to be column names instead of row names. All right, so again, this looks better. But now, remember that I kept on talking about how those refuses and the don't knows, they weren't that informative. You can really see that when we start looking at the bar plots. Notice that refuse and don't knows are represented by the colors blue or green, but we don't see blue or green anywhere on the plot. And again, it's because those counts are so low. And if we look at the reviews for education, that bar is almost 0. And this is going to be true for majority of the variables in the BRFSS. So that's another reason that we remove them. They not only clutter up our tables, but they clutter up our bar plots. But just like with our tables, we want to put, a footnote on these plots that says, hey, we've removed these, so we're transparent in how the data was cleaned. So now, notice what I've done here is I'm going to use that EDU walk table 2. I've got that transpose, so I'm going to be having, instead of my rows, my columns on the x-axis. And the walk table 2 was the ones where I had removed the don't knows, not sures, the refusal ones. Now I do need to make another change here. My x-lab is now going to be education, so I do want to make sure I get that changed in there. And now I've only got two colors, because remember I've removed the don't knows and the refused, in other words this blue and green category, because we're using the EDU walk table 2. And then again I want column names. So let's run this. And this is my new table, or my new plot. So notice, in making the comparison between this plot to this one, we've made some big improvements. We got rid of those categories that were just so low it wasn't really informative. We got rid of that refusal. Now I do think the argument could be made, again there's only one person in this category for the education variable. I think we could make the argument to remove it as well. But now we can look across and we can see there's a much bigger bar for no in all of these than there are yeses. But since we have frequencies, it's still really hard to compare. What we really want to compare are those conditional proportions, just like we did in the table. And so now I'm going to show you how to make this stacked with the conditional relative frequencies. And so this will be the code that you want to use for your report. So for your report, you don't actually have to create any of these 3 plots here. This code is just, again, for illustration to show you kind of some of those changes that we're making. These 2 pieces of code are what you're really going to want for your plots. So to make your plots, you can either do side by side or the stacked. I'm going to show you both of them. So the first one is the stacked, the second one is the side by side. So some things that you're going to need to do. Notice here I've got the EDU walk table final. This is the final table that I made up here. So similar, when I was building the table, I showed you lots of different options. You don't have to go through all of those options while you're building your tables. Now, going through those options, helps you kind of see what's going on in those removals. So, part of that's good to go through because you're going to see those pieces you removed and to keep track of that. But really the table you're going to use for your report is when you get down to this final one. This final table, once you make that, that's what you're going to use for your bar plots as well. So if we come down to this bar plot, I've called that final table. I've used the transpose, so my columns are going to be on the x-axis. Again, I need to make this change throughout. All the x-axis, x labels should be education level because that's going to be your demographic variable. The column names are going to come from the table you put here. So whatever table you have here, have column names and then that table here. The colors, this is going to be dependent on how many levels you have in this table. So again, looking at this table, I can see that I have 2 levels for the columns rather, so I've got 1 to 2. So however many columns you have in this table, you want 1 colon that number. And then your YLab is going to be relative frequency within, and here it's really within education. So again, this is going to be fixed on the file that you download. So now if we run this, notice we've got an even better improvement. I can very quickly and easily look at this plot. I can see that as education increases, the percent of people that are saying no, that they don't have trouble walking, that percentage is increasing. In other words, I've got more pink, and the percentage of people are saying yes, they have trouble walking or climbing stairs is decreasing. And so again, I can see a clear association by whether or not someone's having difficulty walking and climbing stairs and education. And so when you talk about this plot, you want to talk about each bar represents the conditional probability or the conditional proportion on that level of education. So notice each of the bars, the total is 100%, just like in the rows of the table, each of the rows total to 100%. So for example, for everyone that was in the elementary category, it's about 45% of them said yes, they had trouble. 55 said no. When we get all the way up to college graduate, we only have about 15 saying yes and about 85% saying no. So again, it gives me that very quick look. Now, let's say that you want to pick some colors for your bar plot that would look better with your report. You don't have to do the 1 to 2 trick. Another option is you can specify what colors you want. And you can do it this way. So you give the names of the 2 colors that you want, and then you put them both in quotations, separate by a comma, and then have C and then the parentheses. And so if we do this, now we get that. And so that's an option if you want to specify your own colors. Doing something very similar, except we want to have a side-by-side bar plot. The only difference between these, and again I'm going to change this here in your file you have, is I'm going to add in this beside equals true. And so if I do this, it makes a side-by-side. And if you add each of these bars, the height will add to 100%. So these 2 pieces of code are what you want for your report. Now, if you run into trouble with your legend and your legend is covering up some of your bars and it's making it hard to read, you can change your legend, and I'm going to show you how to do that. So I need to make some changes here first, and again, these changes will already be in the file that you have. All right, so that now should look like what you have in your file. Let me run this and show you what this looks like. So notice I just moved the legend over to the left-hand side. And so to do that, I just added in this extra line of code right here. And so if you need to move it around, use this one. And here you can change this to be top left, bottom left. You can change the position to move it where you need it to be. And so that will really depend on the overall shape of your individual plot. And so this is all the information now that you need to work on the worksheet and for your report. Here at the end, though, is some extra information for you, and you can ignore these. That red that it's giving me isn't really an issue. It thinks there's an issue, but I promise there's not. So here on the scatter plot, let me just save that. Sorry about that. I paused and fixed those the red pieces. So what I was saying was these rest of this piece, these are optional. You might in the future need to make scatter plots or make those regression lines that we talked about. So I've included some extra code here that you can look at on your own and ask me questions if you have them. But this is how you would fit a regression line and make a scatter plot to compare two categorical variables. But since the majority of the variables in the BRFSS are categorical, you don't actually need to do this for the report or for the worksheet. So I'm just including it here as extra information in case you need that in the future. So as always, if you have any questions, please let me know. You can always send me your code and I can take a look at it to figure out, if there's an error or, to help get you back on track. So please ask me questions anytime that you get stuck.